Welcome to you from my actual computer, not the VCL. That's very exciting. We're going to be working in Python 3 today, and it's going to feel a little bit like R because we have a lot of packages. But hopefully you'll feel comfortable on your own computer and having everything right in front of you. I'm going to navigate to my desktop in case I create any files. So your experience may be slightly different because you're on Windows or a Mac, but it will be mostly the same. So if you have idle, you can use it. I don't even know if I have idle. I have idle, but I don't know if I could even open it. But yes, I can. So you can open idle, or you can work directly at the command prompt. It's fine either way. So let's say you're working at a command prompt. That's either going to be terminal or PowerShell or command line. You open up and you see if typing Python will get you into Python 3. Nope. In this case it gets me into Python 2, so I have to type Python 3. But it depends, so that I don't care what these other numbers are after the first digit. I'm only concerned about that first digit as long as it's 3. Yours is probably like 3.7 or something. Alright, now one little wrinkle that we have to deal with is that we may be in the wrong directory. I happen to be in the desktop because I put myself there before I opened Python. But you may find that you're somewhere entirely different, and if so, sorry, I meant to write this. If you want to see what is in your immediate vicinity, all the files and folders, and there's a lot of stuff you can't see normally that you can suddenly see. So all this stuff is what's on my home directory on my desktop. And so I know that I'm in the right place. But if I want to go up, I can go up a directory. Single or double quotes are fine. You're in Python, it doesn't make any difference. And then this shows me, this shows me where I am. And oh, there's all sorts of cool stuff. Okay, so I'm going to go back down, and I'm going to go to desktop, and hopefully I'm back home again. And I see that I'm back home again. Alright, so you can navigate up and down. If you know the exact path, you can go directly there. Actually, before I do that, I'm going to just make sure I know how to get back. And the output for get CWD is the same as the input for the next command I'm going to show you. If I want to change directory, if I want to go directly to, say, the C drive, hopefully it'll work. Well, maybe it didn't work. Let me try that. I don't know. I did something wrong. Anyway, wherever I am, okay, I didn't go anywhere. But if I had gone anywhere, I could always change directory back to home, and then I'm back where I was. So sorry that was a bad example. I can go up a level, up a level, up a level, up a level until I can't go up anymore. And I'm up at the top. See, I can't go anywhere else. Once I'm at the top, I can't go down. But I can always go directly home, and then I can verify that I'm back home. Okay, so that's all you should need to get yourself in the right place. And I apologize for that, but I don't know a better way of helping you through, and you may end up in a place where you can't store your files, you can't find them, so you need this utility in order to help you get around your computer. If you're going to be looking at files and saving files, you need to be focused in the right directory. Okay, so that's out of the way. Now we try some very basic Python commands. You can do normal calculations like you're used to. If you want to do a modular arithmetic, you want to know what the remainder is when you divide 100 by 7. So 100 divided by 7 is 98, but then the remainder is 2. So that's how you calculate that. If you want to use exponents, you have to use a double star. Notice that this is not an exponent. It's actually like bitwise and or something like that. It's a bitwise thing, and I'm not worried about it. It's just not it's not an exponent. That's the important part. So if you want to use the square root, you can import a package, or you can just raise to the power of 0.5 and it already does it for you. Vectors are pretty straightforward in Python, and you can sum them up pretty easily too. And you can have this kind of thing going on. You can have weird shapes of your data. It doesn't matter, you can just index it. Notice Python starts indexing at 0, not 1, and that's out of bounds. Oh, Python does something cool too. If you want to see the last element of something, you just say -1. If you want the penultimate or second last element, you put a -2 there, and so forth. So that's a really cool thing about Python. Okay, another cool thing about Python is you get something called dictionaries. I'm going to make my first dictionary called D, and I want uno to mean 1, and I want dos to mean 2. Okay, so then I can ask for uno this way, and it'll hand me back a 1. You can have multiple keys going to the same value, but every key has to go to a unique value. So if I said D uno equals 1, then you see it changes it in the dictionary, so it overwrites the previous one. So that's how the dictionary works, like what you would expect a dictionary would look like. It's just a one-way dictionary. It doesn't go backwards. It's actually quite a bit of a pain if you want it to go both ways. And so this is beyond the discussion we're having today. But you have to only think in one direction for a Python dictionary, only goes forwards. Okay. All right, now let's move on to our packages. And let's start by importing some things. We'll import one more thing later, but we'll start off with our standard 3 things that we use a lot: pandas, numpy, and matplotlib, just the plot part of it. These 3 things are very common, and they're commonly imported together like that with those nicknames. You can use any nicknames you like, but these are by convention only, and we adhere to this convention because it's kind of nice to be able to read other people's code and follow along what they're doing. Okay. So here I am creating a dictionary, and I just want to show you what it looks like. I just overwrote my old dictionary. I have a column 1 that goes to a vector 1, 2, and column 2 goes to a vector 3, 4. And notice the dictionary does not honor your ordering. It actually puts it in its own special ordering, and it's none of our business how it does that. We'll never know, but it's really, really efficient, and it allows it to look things up very quickly. It's kind of almost like alphabetizing, but it's alphabetizing according to its own algorithm, not according to what you think it should be doing. Okay, so don't try to figure out why it switched them. It just did, and we don't care why. Okay, now we have data frames, and this is the point of what we're doing. We're going to start digging into data frames, except that what just happened? Whoa, I meant to write PD, not PDF. Okay, there we have a data frame, and we want to look at it. A very tiny data frame, and it's just 0, 1, 3, 1, 2, 4. What does that mean? Well, 1 and 0 are the indices, and then this other 4 items, the 1, 2, 3, 4, that is the data. So column 1 has data 1 and 2, and column 2 has data 3 and 4. And I'm going to pause this a second to see if I can increase the font size. Okay, maybe this will make it a little easier on your eyes, because this is going to get kind of intense. So let's continue. All right. So we're looking at the data frame, and what if we want to add to this? I'm going to make another column in my data frame. And what if I want to add a column that is entirely the same item multiple times over? I can just put one element in as an argument and send it off, and it will work. So see what happened? The 6 and the 7 went in just as we expected, but the 1 just got replicated as many times as necessary to fill up the whole column. Okay, kind of boring, I know, but there it is. All right, so let's make up a new data frame. And it's going to be like this, 5 and 6, and then it's going to be 7 and 8. And that's what my data are going to look like. And I'm going to give names to my columns. It's not necessary, but it's a nice gesture. Hey, we're in Python. We may as well demonstrate the fact that single and double quotes are both acceptable here. Okay, so now what do we have? We have data frame 1 and data frame 2. Okay, there we go. What would happen if we were to try to glue them together somehow? There's an append command, and we're actually going to do a lot more data frame calculations in a different module, in the optional module, but we have to know a little bit about what we're doing right now in order to get through these exercises. Okay. Does it matter which order you append to? Yes, it matters. And so if I append df2.append df, then df2 is kind of the one in the upper left corner. So whichever thing you want in the upper left corner essentially ends up, you put it first. But notice something really weird happened. We got duplication of indices, and that's not good. So let's do the following. Let's say ignore index equals true. I don't know why that's not the default, but now it is. I can just say, look, I don't want duplication of indices. I want a new index. Great. Okay, so now what do I want to do? What if I want to save it? And since I'm just using df as a throwaway thing, I'm just going to write it on top of itself again. And now I'm going to say D3 is some tiny little set of data. It's going to be a dictionary with one thing in it. Very tiny dictionary. And I'm going to create a very tiny data frame to go with my very tiny dictionary. There you go. World's smallest data frame. Oh, at least a super small one. What if we glue these together? What would happen? This is what would happen. Okay, so we can do that, and we may as well do that. I don't know what I'm doing. I'm just sort of, I'm following my instructions, but this is just a demo. So that's what's happening. Okay, now, what if I wanted to do the following? There's a column 2, and position 2, what I really want is right here. I want to change that value to something. Okay, so I'm going to maybe set it to 9. And it let me, but sometimes it will yell at you because this is actually poor form. And what you should do is you should use this command, location, which is 2, and then let's say new column, and then maybe equals 99. So now you can see we put the 9 where we intended to, but we also put the 99 right next to it. So there's 2 different commands you can use for updating elements, and depending on your system, you may or may not get yelled at for using the first command I showed you. It's considered poor form, but it usually works. Okay, now what if we want to save this, whatever our results are, we want to save to a CSV, and if we do this, we can save it. Let me see if I can find this now. Here's my CSV, and I'm going to open this up and show you that it works. Everything that was NaN turns into an empty spot in my data frame, and so I can just use that anywhere I want now. Okay, it's a CSV. You know and love CSVs, so that's how you do that. Okay, moving right along. We are going to base the rest of this tutorial on the data we've been using in class, and we're going to use read CSV to get there. I know, this is like a typing exercise. We're almost done. We only have to do it once every so often. Okay, now we want to reassure ourselves that we got our data, and so we look for the phrase my data somewhere in my listing of what I have. I still have D, D3, DF. We're going to just write all over top of that. But we've got NumPy, we have Matplotlib, we have pandas, and we have some other garbage we were creating before. Okay, I can also look at the shape of my data, and it tells me how big my data is. I can look at the data types in my data, and I can do a quick describe on my data, and it gives me a quick summary of the various elements that are in it. Okay, now what if we want to do mean, median, and mode? These things are not a problem. So I want to look at all the data for the column male and look at the mean. And we know there's 40% male. Anyway, the median is 0, which means not male or female. So the typical thing we have in the data is a female. Mode is going to be, well, that doesn't make any sense. But anyway, the typical male is male, and that's kind of pathetic. But I just wanted to show you the command doesn't choke. It's really there. And the exposure column, I can describe that. I may as well do mode here. I think 17 is the mode. I will find out. Oh, 14. Okay. But we can find the mode on something that isn't pathetic too. Okay. Now we'll move on to scatter plots. And there are so many ways you can do this. Now, nothing is going to show up, but it tells us that we've created the structure. So this thing that comes in, this greater than, less than symbol, that's great. The less than, greater than, so it's fine. We are good. We're going to see something soon, and we just have to say plot show. And I really don't want to keep this up forever, and so I'm just going to close it down. And if I want it, I'll bring it back up again. I mean, it's gone forever, but I'll just execute it again. Okay, what about if I wanted to use a plus instead of the default symbol? I can do this, and I get little pluses instead. Then that looks more like the data I'm used to. Well, that's because when I did my scatter, I did not do C versus exposure. So that's what you're used to seeing. Okay, so all different things you can do. You might ask, well, wait, can I just do this? I don't know. I'm just gonna try. Yeah, it doesn't like that. Let me try that. Yeah, it doesn't like that. So each command has its own little ways that it wants you to gift wrap its data. So the plt plot command is from the matplotlib package, and so it expects things to be packaged differently. Whereas this scatter plot, it's just a normal scatter plot that you don't need. Well, it's just using. It might be using the pandas package, I don't know, but they're using different packages, and that's why the way the command looks is different. So there's ways of converting between these different types of data structures, and so you might have to look up how to do that, but if you just follow the examples as I have them written, they should just work. Okay? Alright, so what are we doing now? A different scatter plot. Okay, I want you to see this scatter plot matrix, which is really cool stuff. And I'm going to use every observation, but I'm going to look at C, which is current temperature. T8 pH is today's predicted high, meaning the day I did the observation. If you recall, the reason I had done this, I was trying to see if people expose themselves more based on what today's temperature was. But I also threw in yesterday's temperature as Y, C is the current temperature, and TPH was today's predicted high. Because I wondered if people are like me, if they dress based on yesterday's weather, which is what I often do. Okay, again, I shouldn't see anything. Oh, scatter matrix, because what did I do? Something is not right. Did I forget to load something? Hold on a second. There we go. Yeah, I forgot to import something, so I need to do this now. So I'm going to go from pandas, tools, plotting, import star, and then this command should be fine. Okay, and then I'm going to go ahead and do a plot show on that, and then I get to see all these cool plots, including this guy down here is what we're used to seeing. I usually plot current temperature versus exposure, but what this does is it gives you a nice little histogram. So obviously a plot of C versus C would just be like a straight line, and that's pathetic. So instead, then it gives you a little histogram on the diagonal, and then for example this this graph is going to be mirror image of, well, it's flipped, or mirror image or something of this graph. It's going to be essentially the same information, and this information is the same as this information, everything on the diagonal. It's just diagonally symmetric. So anyway, there you go. Great. Okay, now moving on to the next thing. So simple line plots. Okay, and then I'm going to do a plot show on that. And it's a complete, horrible, awful mess. And I'm going to make a sorted version of that and plot it out so I get myself a cumulative frequency distribution. And that will be a good stopping point at that point. Notice the type of X is the same as the type of the whole data frame that we're using, which is my data, so they're the same. So even though I'm just pulling out one column, it's still storing that one column in a data frame. Okay? And I'm going to say sort values by exposure, but guess what happens? It doesn't actually sort X, it just temporarily sorted it. Notice that X does not change. So what I need to do is I need to store it in a new variable, so I'm just going to call it Y. And now if you see, Y is permanently sorted, and now I can turn it. So remember I just said sometimes you have to convert these guys. So this is how you can convert a single column data frame into a list. You use the toList command, and now it's a list. Whoops. But it's not stored. Okay, but that's what it looks like if you use that whole command. And so I need to plot that. So I'm going to go ahead and plot this. And then I'm going to do a plot show. And then I have this not disgusting thing. This is just a cumulative frequency distribution, and this is right at 14 where you know, so the flattest portion of the curve is going to be where your mode is. And okay, that's a good stopping point for now.